Hi there, I'm Colonel Robert Epstein, Commander of the Air Force Agency for Modeling and Simulation. Wanted to let you guys know today that as we're giving you this presentation, we're doing it in COVID-19 pandemic response mode. So we're using social distancing today. So as you see my other speakers come on board, you're going to see them magically appear and disappear in the screen. Don't be concerned. With me today is going to be Dr. Alethea Duhon. She's the Modeling and Simulation Chief Technical Officer for the United States Air Force and the Technical Director for the Air Force Agency for Modeling and Simulation. And we also have Dr. J.J. Walcutt, who is our subject matter expert on our topic today. Today's topic is going to be how the Air Force is approaching knowledge management and creating a knowledge management system to improve our decision capabilities and our decision superiority for the future. We find ourselves in another era of great state competition. Peer competitors who've technologically improved over the years, we now find ourselves in a position of parity with them. So the only thing that gives us the advantage in combat or competition is going to be our training and our ability to outthink our adversaries. So this drives us to, how do you manage knowledge? How do you create a learning system and manage the knowledge so that we can present it in a digestible way to give ourselves decision superiority? Our current situation is somewhat complex and very siloed. So these siloed areas of knowledge are forcing us to make imperfect decisions because we don't have all the information that's actually been collected and available to us. So how do we get it where the objective data rises to the top and gives us that ability to create decision superiority? Well, first we need to have objective data. We need to collect it and actually have it in some digestible way that we can make those decisions. We need to have informed decision making, which is really going to come from having that data, and we need to leverage technology. We need to leverage artificial intelligence so that we can actually process and fuse that information into usable, digestible information. And to do this, that's going to give us the advantage in combat. If you think of the OODA loop, the observe, orient, decide, act process, we're very good at observing others. We orient ourselves based on the observations. What we're talking about right now with knowledge management is, how do I process and fuse that data that I can actually take all my observations and make better observations so that we make better decisions? What we're finding is this is both a human science problem for how we learn and how we process information, and a technical problem for how do we actually fuse that data together, how does it actually flow and get combined, processed, and accessible to the user. And for that, the Air Force Agency for Modeling and Simulation commissioned a study, which recently concluded, on the U.S. Air Force's knowledge management system. And with that, I'd like to turn it over to Dr. J.J. Walcutt, who can talk about what we did with the study and some of the findings.
Thank you, sir, for that great introduction. So for those of you who don't know me, I'm Dr. J.J. Walcutt. I'm the former Director of Innovation for the Advanced Distributed Learning Initiative. And under this report that they commissioned for the Air Force, what I did was come in from that perspective of distributed learning and start wondering, how do we look at knowledge management a bit differently? Typically, we start with a set of requirements, and certainly in this case we did the same thing. But as we looked at those requirements and really tried to understand them, what we realized is that we needed to take a step back and not just expand what we currently have for knowledge management, in other words, creating the ability to capture more information, but rather we needed to be able to organize it differently so that the individual who's the decision maker, or in this case the learner, is able to digest that information and then make it actionable. And this required us to start at the top. So the first thing we did from a methodological perspective was to look at the national strategies, the Air Force strategies, and all the policies that have come out recently. And if you're following what's been happening over the last 3 to 4 years, we've become more data-centric in our requirements. We're looking at understanding better how we use both the science of learning and also the data that's available to be able to make this information accessible to all those decision makers. And then we took from that stage, then we made a new set of requirements that said, how do we not just expand, but rather move into the next generation? Ironically, this overlaps distributed learning immensely because, of course, that decision maker is a learner, and how we present that information becomes as important as it is for how we present information to trainees. Ultimately, we're trying to, as the commander mentioned, really target that space in that observe and orient location across the OODA loop. How do we get enough information from disparate locations or conceptually from different areas of research or operations and be able to bring that together, understand those patterns, and then present that information to an individual who can make better decisions than we've made in the past. The recommendations that we found out of this really fall into two key areas, as you mentioned. It's the human side, in other words, that presentation of information, and then that data side and the technology piece of it. So much of learning science for the last couple of years, really I would say for the last decade, has been preparing for when technology is at a pace and a precision point where it's interoperable and able to be used to our advantage. In that time frame, what we've been able to do is figure out how to manage cognitive load, how to ensure that the individual is getting just enough information to be useful and not too much to be overloaded. We've also been looking at understanding how to highlight or showcase patterns, whether those are in an operational setting or those that are in a data management situation with computers. And what we're able to do then is utilize that information to show what a human couldn't achieve on their own. And then last, what we're able to do, and what we've really been looking at, is this human interoperability. How do we make sure that all of us are connecting when we need to? How do we make sure that we use social learning capabilities so that what my colleague knows is also benefited to me, and what I know is also benefited to them? Being able to share that information means that no single person is making the decision alone, but is doing so with the benefit of a team, but maybe not making a team-based decision. And so with that, I'll go ahead and pass it to Dr. Duhon, who will talk a little bit about the underpinnings of all of this and what the technological challenges and also the wins that we've achieved so far.
Hi, I'm Alethea Duhon. I'm the Technical Director for the Air Force Agency for Modeling and Simulation, and I'm also dual-headed as the Modeling and Sim Chief Technology Officer. Today I'm going to talk about the technical challenges that we were discussing initially. The two things that I see that are of interest is data and technology. Data itself is the foundation for artificial intelligence and all the underpinnings of what we're talking about. Technology itself, I see it as a catalyst and a driver for bringing that technology to the masses. So the one thing that I wanted to discuss in terms of what we're doing is creating what we call, if you watch Ready Player One, OASIS, the data-centric environment that we are trying to adapt to, or the digital twin of the world that we're trying to create. So what does this mean when we talk about data, artificial intelligence? You hear digital engineering, all these terms being spun up. How does it apply to what we're doing right now in the Air Force? So one of the efforts that we're doing is the data-centric synthetic environment. So that means looking at the cloud modeling and sim framework, and also the services. So that's creating a sandbox for hosting this digital environment, whether it's in the cloud, so that we don't lose the fidelity and also incur latency. Another thing that we have to think about in terms of digital engineering, everything, is the authoritative data sources. We need to provide this federated data source that delivers access to the raw, semi-processed data from various data providers. Another thing that we were talking about is the common ontology, so the common language, a common shared understanding of how the data is processed and enabled for data tagging purposes. Another aspect we're talking about is the modeling and sim digital environment, which is the sandbox for the various generators, let's say terrain, weather, so that we can see the same weather when we're fighting and training together. The last key aspects I like to harp upon is the multi-level security and the zero trust. We need to allow data tagging and accessibility of credential mapping to ensure that we create the true MLS solution. So those are the various aspects in terms of what we're doing in the technical realm to generate meaningful and useful data, objective information that decisions makers can make to inform their decisions to enable ready and lethal force.
So based on the technological advances that the Air Force is making, how is this acting as a challenge to the knowledge management system, or how we're approaching knowledge management?
so often we think, great, we've made an advancement, and so now the benefits will come to us and they will just magically happen. And of course, that is not realistic. What's happening instead is that we have these capabilities, and not only do we have these capabilities, but the rest of the world has these capabilities as well. And so now it becomes upon us to actually use and benefit from the technology advances that we have available. And that's where we get into this training and learning science space. Particularly what we need to do is recognize that, number one, we've got to be collecting data. Data. I can't stress it enough. We need to be collecting the data, and we need to be collecting it correctly so that it's mineable. The second thing that we need to do is help our decision makers, those who are deciding how we're going to invest our monies going forward, to understand that we can't just expand, but we actually have to be able to access information differently. So unlike what we've done today, which is to create these silos or folders of information where everything is in its own pieces, organized by the individual who made it, where we need to go to is a place of a different concept where the data is streaming, the information is constantly changing, the environment is evolving as quickly as the operational environment. And we are able to then mine that information, but do it in a way that's helpful to the individual. Otherwise, we'll end up having random pieces of information captured, but no real clarity as to what that message is to help the decision maker. So I think from a learning science perspective, we really are focused on those three key areas. How do we make sure that the load, the cognitive load for the individual is managed? How do we make sure that the pattern analysis is above and beyond the individual human? And how do we make sure that all of our research communities and our operational communities and our decision-making communities are actually working together through these kinds of forums?
Thanks, JJ. It's obvious that that's going to create a technical challenge for us. So let me go back to Dr. Duhon. How is this going to pose challenges, or what do we need to do technologically to sort of not have just random bits of data, but actually fuse that data and make it usable?
So the one thing that we've encountered during data collection itself is obviously the meaningful data that we acquire. One thing, at least, for instance, the test and evaluation, we have to be cognizant of the factors, the levels, the interaction, whether it's a first and second order effect. So it has to be meaningful data. Let's say you like to play golf. In golf, there is a noise variable, let's say wind. So those are the things that we have to think about. Is there an interaction? Is there a factor? Is there a cause and effect relationship of that? So in terms of acquiring the data, one thing we have to do is ensure that we design the appropriate way to collect data, so that when we update, analyze, it can be done in a very robust manner, so that to ensure that what data coming in is meaningful, objective, and also digestible to the decision makers at the end of the day.
So what technologies do you see right now that are emerging that are going to help us solve those problems? Specifically, I'm thinking with regards to getting away from net-centric, the artificial intelligence, the computing power. How are those going to really enable those things to occur?
No, that's a great question. So there are a lot of things that advances right now in technology. As you can tell, the computing power is there. Many years ago, that wasn't the case. I'm sure a lot of the engineers out there can relate to me when we used to write our own function, our own codes. Now, back then we had to do parallel computing and certain aspects just to ensure that our code is running efficiently. But now with the rise of artificial intelligence, deep learning, machine learning, and all those tools available, it enables and optimizes our output right now. But again, data is as good as what we make it. At the end of the day, it is still the human piece still has to be in the loop. So we need to make sure that we're training and optimizing the way we train these machines to enable that we have that meaningful data. So I can't stress enough that with the rise of technology and artificial intelligence and all these other aspects of technology, we must ensure that at the end of the day that we be good data scientists, that we ensure that we are capturing the right information and that we are realizing their interactions and a cause and effect relationship, so that we collect, again, objective, meaningful data.
Fantastic, but that brings up the next point, which gets into leadership has been saying to do these things for a long time. How do we actually, with the policy that we have, facilitate these things happening? Dr. JJ.
It's one thing to put it in an instruction. It's another thing to share it with leadership and behind closed doors get a, yeah, that sounds great. But we have to have the authority. We have to, no kidding, have the directives. We have to have the policies. The strategy has to match. We have to have the authority with the money to be able to actually execute. That's the formula. So one of the things we did through this project, as I mentioned, was actually to go through those policies and determine at the DoD level as well as at the Air Force level, and including talking to the Army and Department of Navy as well, is everybody on board? Is this something that we're all going to be moving to? Without question, the policy is very clear over and over and over again, whether we looked at the data pieces, the interoperability requirements, the knowledge management structures, science and technology strategies that require us to not just recognize technology, but actually utilize it to be able to move us into that next generation phase. And what that really means is look at the problem from a different perspective. Don't expand. Make sure that you're evolving so that you are constantly able to mine data that is changing in the system, that is chaotic, that is unclear, but then be able to make it clear. So I think we're really at that point where I like to say we've kind of hit stupid math. It is a requirement by policy. It's a requirement by strategy. More importantly, though, it's a requirement for us to remain as an authority in the world and the global force space. If we're going to be competitive, we can't just be using our best single ideas. We have to recognize we have to work together. Now that the policy's in place, we need to get those authorities clear. We need to get decision makers to yes. We need to make it tangible and understandable what it is that we are trying to build and make sure that the money is flowing to support across the different communities so that we're working together and sending the same message.
No, that's excellent points. The one thing I notice also in terms of technology is technology galvanizes the different ways of how we think. For example, a data scientist, an engineer, a statistician, even a strategic leader might have a different lens of how we view the data. So it's very important of how we also present the information. I talked about the design of it, but in the analysis of it, but how we present the data also and how we optimize it to the correct viewer, because we come from a different perspective, a different lens. So that's one thing that technology enables us to do.
No, that was perfect. It really highlights the fact that we need to have personalized knowledge management. This is going to get into, based on the role of the individual, how do we present that information, the same information, but through a different lens, so it becomes actionable intelligence that we can work with. With that being said, this is the point where I'd like to start wrapping things up. So the recommendations that we're making from our report and our study was that we need to get away from what we currently are doing for knowledge management. Locally created data, stored locally, having unique goals on a local network, and manually processed, getting to the future that we see is going to really give us an advantage in warfighting, which is anybody can create the data and put it into the system, that we use standardized ways of putting it together, that it's stored externally and it's accessible, and that can be analyzed and really take advantage of the technology today to fuse that information into actionable data. And then, how do we get it out there to the people to actually act on it? These have sort of been identified, and we have a strategy over the next few years on how we're going to go from where we are today to where we can actually start implementing and taking advantage of this. With that, I thank both of my panelists, Dr. Duhon, Dr. Walcutt, for their expertise, subject matter experts, and their willingness to participate in this. I thank you for taking the time to listen, and I look forward to leadership and researchers listening to this and being able to move out to help us facilitate what we think is going to give us a competitive edge in warfighting.